It should start now.
Yep.
Perfect. So that's up and running. Yeah, I think this is a good time to start. And if people join later on, they're welcome. They can do that. Okay?
Yeah, sure.
Okay. So welcome everyone to this next level into Dapr. So the advanced version of Dapr. So a few weeks back, we had the introduction to Dapr by Michal. And today, Sandra and Edwin will continue talking about Dapr, some of the more advanced topics like access control, rate limiting, and walk us through that part of it. So thank you, Sandra and Edwin, for joining in.
Yeah, thanks for having us.
The stage is yours, Sandra.
Awesome, thank you. So let me share my screen here and switch over to PowerPoint. Can you see it, Edwin?
Yes.
Awesome. So yeah, thanks for having us. My name is Sander Molenkamp. I'm a principal cloud architect at InfoSport. It's an IT consultancy company in the Netherlands. And I'm joined by Edwin van Wijk.
Yes, I'm Edwin. I'm a principal architect also at InfoSupport in the Netherlands. And we're both Microsoft MVPs, and we're going to talk to you today about advanced Dapr stuff. And we all would like to do that, so we are looking forward to this session. And thanks for joining us.
Yeah, and so Michael left us at the end of his introductory talk with a understanding of the building blocks, and we'll pick up from there. But before we get into the more advanced stuff, we still like to do just a little recap. It's just a couple of minutes, just to make sure that we're still all on the same page and that the general information is fresh in your mind. So I will start with that. And then after that, Edwin will talk a little bit about traffic control sample application that we created to demonstrate some of the Dapr building blocks. Then I'll have a look at how you can harden your systems for production, how you can add some more levels of security to your system. Then Edwin will show you how to integrate Dapr with some other Azure services, such as Azure Logic apps. Then we'll have a look at how you can extend Dapr, because Dapr is very extensible. You can write your own components to add functionality. So I'll be showing you how we add a component and have a demo on that. And then finally, Edwin will talk a little bit about rate limiting and middleware and how you can do all of that stuff. So this will take, I guess, about an hour. I think we've got an hour scheduled, so that should fit. If you've got any questions, please post them to the chat. I believe Michael is monitoring the chat and will let us know if there are any questions that we need to answer. So yeah, without further ado, let's dive into the recap. So Dapr. Dapr is basically a set of building blocks that makes it easy for you to create microservice applications. So each of these building blocks that you see down here on the slide solves a particular problem that you may encounter while building cloud-native microservice applications. So for example, service-to-service invocation helps you discover and call other services. State management allows you or gives you a key value store, so you can create stateful long-running services. So that's not really a replacement for your relational database. It's much more intention to store transactional hot state. Then publish and subscribe allows you to use pub/sub messaging between services. Resource bindings and triggers allow you to interface with external systems. That looks very familiar to the way that Azure Functions use bindings and triggers. Then we have an implementation of the actor model with the actor building block. We also have a lot of features around observability, so you can get a lot of metrics out of Dapr and you get distributed tracing out of the box. And we also have a secrets building block, which allows you to very easily manage your secrets. And as I've said, all of these building blocks are extensible. So these building blocks basically provide the abstraction layer and the API. and then components that you plug into these building blocks provide the specific implementation. So that API is available through either HTTP or gRPC. So you can use both to call these Dapr building blocks. And because those are really standard protocols, you can use these building blocks basically from any language or framework. But sometimes you want a little bit more native experience, and that's where the Dapr SDKs come in. So for example, for .NET, I'm a .NET programmer. There's a Dapr.NET SDK, and I use that when I want to build systems with Dapr. You've also got SDKs for Go, Node.js, Python, I believe, well, all that are on the slide, plus PHP is also being released now. And then what we're seeing is we start seeing Dapr more and more into coming into these higher level frameworks and products, such as, well, for example, functions, which now has native support for Dapr, logic apps and API management, which Edwin will get into. So here's a pretty huge list of all the components that you can plug into Dapr. So the slide says 71, but it's actually outdated already. So I think we're at 75, 76, something like that. Edwin also created a component for, what was it, Edwin, SMTP? Or yeah, for sending mail to just a generic SMTP server. Mm-hmm. And later on in the session, I'll show you how you can create your own components and also how you can get it into the product. So the really important thing that you have to understand about Dapr is how the building blocks are exposed to the application. So Dapr uses a sidecar architecture. So that means that your application doesn't have a direct reference or a direct dependency on Dapr. Instead, your application and Dapr run alongside each other. And that can either be in a separate process. In that case, we talk about a self-hosted scenario, or as a separate container in a pod running, for example, on Kubernetes. So all communication between your application code and Dapr is inter-process communication using that HTTP or gRPC API. So here's a small example for that. So let's say I have a service A, and I've deployed this on Kubernetes, so it's running in a pod, and I've got two containers in there. So my application code is running in its own container, and then I've got Dapr running in this sidecar container. And now I want to store some state. So my application can call the API of the state management building block on the Dapr container. Then the Dapr sidecar will go look at its configuration, which is just a YAML configuration file, to see which state store implementation I have selected to store the state in. So let's say I've got this set up to store the state in Redis. Then the Dapr sidecar will use the Redis component to store that state inside the Redis database. Now, because the Dapr sidecar abstracts away all the details of how the data is stored, and because I can simply configure that in a configuration file, I can now very easily switch implementations by just changing that configuration file. So if I would go in there and change Redis to, let's say, Cosmos DB, then my application can now save its state in Cosmos DB. So that's very easy, and I don't have to change any lines of code in my own application code to get that flexibility. Let's look at another example. Let's say that I now want to call another service. I want to call service B. Now with Dapr, I'm not calling the application code of service B directly. Instead, I'm going through these sidecars. So again, I'm making a call from my application, from the service A application to its Dapr sidecar, and tell it from, hey, I want to send this call to service B. The Dapr sidecar will use its service discovery mechanism to figure out where service B is. And then it will make a call to the sidecar of service B. And then that sidecar can make the final call on the application code. And of course, if the if service B returns anything, then that will flow just over that same connection. But because we're now going through all of these sidecars, Dapr can inject a lot of interesting functionality because now it can use MTLS to secure the connection. And it can inject retry policies if anything goes wrong. We also get a lot of observability out of this because Dapr knows exactly what we're trying to do or which hubs we're making. So we get a lot of distributed tracing for free. Or basically for free. We do have, of course, a little bit of latency, but that's really small. And they've done some extensive performance tests on this to show that it's really single digits milliseconds. So this is just an example to get that whole Dapr mindset first up a little bit. Now let's look at the sample application that we've built. So I think you are going to take over my screen now, aren't you, Edwin?
Yes, I will. Let me know if you can see that.
Yeah.
Yeah. So the sample application, I guess that Michael also showed this in his session the last time, but this is a traffic control sample. And this is something that we see on a lot of Dutch highways. We have some kind of a speed trap. So we have some entry cams and some exit cams. And when a vehicle passes the entry cam, the entry cam will make a picture of the license plate of the car. And when you pass the exit cam, it will do that again. And then based on the timestamps and the stretch of highway, the length is of course fixed. It can calculate whether or not you were driving too fast. And if you were driving too fast, then a message will be sent to the Central Fine Collection Agency, and this will send you a fine to your home address, and then you have to pay. So this is how this works in the Netherlands. I don't know if this is also something that you have also in your country, but we have a lot of these in the Netherlands. So we simulate this with a Dapr solution, and there are a couple of services in there. So first of all, there's the camera simulation, and this is just a console application, and I'm going to show another one in a minute, but this is just simulating cars driving on the road. And then we have a traffic control service, and this traffic control service is basically using these cameras. So we have an entry cam and an exit cam endpoint that we can call. And we can send messages to it that says, okay, a vehicle has been registered for entry or for exit. And this way we know that vehicles are driving on this piece of highway. Like I said, if the traffic control service, it will calculate whether or not you were driving too fast. It will send a message to the collect fine endpoint of the fine collection service, which is another service in the solution. And then the fine collection service will get, based on the license plate of the car, it will get some vehicle information. And this will contain information about the vehicle, but also the owner, including its email address, because we're simulating that fines are being sent by email. So this is basically the whole setup that we created, and this is all using Dapr beneath the covers. So this is another way of showing that these are all these components, and you see again they run with the Dapr sidecar. With only the camera simulation isn't. It is just a .NET application, but all the other services run with the Dapr sidecar. And then we're going to use all the building blocks that we've just shown, because first of all, when we send, if you want to get the information for the vehicle and the owner from the vehicle registration service, then the fine collection service will use service invocation to just call that endpoint, just as Sander showed in the simple example before. We're going to use publish and subscribe. So this is another building block. A Dapr building block pops up to, if there is a speeding violation, we will send this through PubSub, and we're going to use RabbitMQ as a message broker from the traffic control service to the fine collection service. And then based on the messages that come in, the Dapr sidecar will call the collect fine endpoint. So that's PubSub. We're also going to save state, because we have to make sure that we save on entry and then get the state on exit and make sure that we have the time span in between. So we store the state of each vehicle in a Redis cache, and we use the state management building block for that. Then once a fine needs to be sent, we will send it using email. Just as I said, we get the email address of the owner of the car, and we will use the SMTP output binding for that. So this is a binding that I've created. We could also use SendGrid, for instance, or whatever, but in this case, I'm using SMTP because it's a really nice way of demoing. And then we're going to look at how the camera simulation will send entry and exit cam events. And it will do this using MQTT, which is a lightweight protocol. And we're going to use Mosquito, which is also a very lightweight MQTT broker for doing that. And there's an input binding for MQTT, so we're going to use that. So the camera simulation will send MQTT messages to Mosquito, and then Mosquito will trigger through the Dapr sidecar the entry and exit cam endpoints. And then finally, we need to connect to the SMTP server. So we also have secrets in there. So we will get secrets from the secret store to make sure that we don't have to use these things like clear text in our code. So we have the credentials for logging on to the SMTP server in the secret server. So this is the whole setup. And I'm going to show this application now. So I'm going to
2 seconds, Edwin.
Yes.
We have a question. So
Okay.
Ellen is asking, do you have any guidance on when to use actors versus services? Presumably this could be implemented with actors.
Yes, and actually, if you wait, I will share the repository that this sample is in, because we also have an actor implementation, but it's not in this presentation. We're going to not touch upon actors, but there is an actor implementation in there. So maybe you can look at that and then see how we implemented that there. We don't have any guidance for now in this session, but there is an implementation in there. Is that okay for now?
Thank you. Yes, let's
Okay.
continue.
Cool. So first of all, let me show you the solution. This is in Visual Studio Code, and you can see all the components there. So the vehicle registration service, the fine collection service, traffic control service, and the simulation. And this is just ASP.NET Core Web API application. So here you see the controller for the vehicle registration service. It has a get vehicle info. And you can just call /vehicle info /license number, and it will give you back some, this is just random information. So it's not actually going to a database or whatever, it's just random. But this is what this looks like. And all these services are basically web APIs, except for the simulation, which is a .NET Core console application. And what I'm going to show now is I have 4 different terminal windows here. Each one is in one of the folders within the solution. So from the top left, vehicle registration, on the right, fine collection, traffic control on the bottom left, and simulation on the bottom right. And what I'm going to do now, and again, you will get all this code later on, so you can look at all these commands, but I'm just starting the vehicle registration service with Dapr. So you see here, my .NET application has been started, and all this other logging is everything that has to do with Dapr and the sidecar that's being started with this one. I'm going to just do the same thing with the fine collection service, and I'm going to do the same thing for the traffic control service. So these are the services up and running. And now what I'm going to do is I'm going to start the simulation. And this is just .NET Run because it's not using Dapr. It's just sending MQTT messages to the message broker, the MQTT broker, and this will eventually call the Dapr sidecars. And well, this will basically start simulating vehicles driving over this piece of highway. I simulate 3 lanes here, but this is something that you can configure. And now you see entry and exit. And this is weird. I get an exception here. Something is wrong. And this happened to me before because it cannot find the service now. So I have to restart it later and try this again. This is not something that has to do something with Dapr. I have a VPN here, and sometimes it's acting up, and it will play tricks on my MDNS. So it's not able to find the service. So excuse me for that, but for now, let's stop this and go on with the presentation. But eventually, this will call everything, and then the messages will be sent. So to go back to the slides. Yeah, that's it. So like I said, we will give you the link to the repository at the end, and then you can play with this. And for now, I'm going to pass it back to Sander. So you can take over the screen and you can start talking about security within Dapr.
Yes, let's do that. Let's go back to PowerPoint. There we are. All right, let me see. Yeah, okay, so security. So we've got all these nice services, and now you want to deploy this solution to production. So what are some of the features that we can use to harden this system? Well, if you look at this picture, there are different areas that we can harden. So for example, we can look at the communication between sidecars and take some measures there. But we can also look at the communication between sidecars and the components. So for example, are all the sidecars allowed to call all the components, or do we want to limit that a bit? And then finally, we can also look inside the pods and look at the communication between the application and its sidecar, and even tighten that up a little bit more. So I'm going to dive into detail on all three of these areas. And let's start with a sidecar to sidecar communication. So here's an example of the find collection servers making that call to the vehicle registration servers. And the first thing to note here is that Dapr out of the box gives you support for MTLS, or mutual TLS. Now with mutual TLS, the server needs to identify itself to the client, and the client needs to identify itself to the server. And if that handshake is successful, then an encrypted channel is established, and those services can communicate securely with each other. And that's something that's very easy to set up. It's basically just a boolean in your configuration to turn it on, and then you've got secure communication out of the box. So that's very nice already. And then the other thing that we can do with sidecar to sidecar communication, and service to service invocation especially, is use access control policies. And with these policies, you can limit which services are allowed to call your service. Now, both of these features rely on a Dapr system service called Dapr Sentry. So Dapr Sentry is basically a certificate authority that generates the workload certificates for the Dapr sidecar. And then these workload certificates are then used to establish the MTLS connection. Now, these certificates also contain a SPIFFE identifier. And SPIFFE is a CNCF standard for providing strong identity to workloads. And with Dapr, a SPIFFE identifier consists of these following parts. It always starts with SPIFFE, then you have the trust domain, NS, then the namespace and the app ID. So the trust domain is just a logical group of applications. So by default, all of the applications inside the same trust domain trust each other and do not trust any call from outside the trust domain. Then the namespace is the specific Dapr namespace, and the app ID is the specific Dapr application ID for the servers. And all of these things combined give you a unique identity for each of your Dapr applications. Now, if we have those unique identities, we can start adding access control policies. So in this scenario that I've got here, the find collection servers should be able to call the vehicle registration servers. But the traffic control servers should not, because it doesn't need to have access to any of the vehicle registration data. So we want the top call to succeed and the bottom call to fail. So how can we set this up? So you set up access control policies inside the Dapr configuration file. So each Dapr application has a configuration file, and which is different, by the way, than a component configuration file. So your application has a Dapr configuration file, then each component that you use has a component configuration file. So this is done at the application level. And in that configuration file, you create an access control section, and then the first thing you do is define the default action. So by default, I'm just denying all of the calls coming into this vehicle registration servers. My trust domain for my vehicle registration service is going to be public. That's also the default value for trust domain. And then I can start setting up some of my more specific policies. So I want to set up a policy for the find collection servers. So I first need to define how I will recognize that it is the find collection servers. So I do that by specifying the app ID, the trust domain, and the namespace, because those are the three parts that make up my Spiffy ID. So now when the incoming request matches this policy, then again, I can set a default action for the policy. So I could have set the default action to allow, and that would allow any call coming in from the find collection servers and deny any other calls. But I don't want to give the find collection servers access to all of the operations on the vehicle registration servers. I want to give it access to one specific operation. So I'm still setting the default action to deny. And then within the operations element, I can specify very specific operations. So here I'm telling it, yes, you are allowed to get the vehicle info / star. Star is just a wildcard. It will be replaced by the license number in the actual calls. So as you can see, it's a very nice fine-grained way to which you can use to very specifically set policies on what's allowed and what's denied. And this is for servers to servers invocation. So let's move over to sidecar to component communication. So here we've got a sample of the traffic control servers, and traffic control servers gets all those entry and exit events, and it needs to store it somewhere. We're using a Redis state store for that. But other services shouldn't be able to just call that state store component. So I want to limit its access. And limiting access to components can be done by going to the component configuration file. So here's an example of the state store configuration file. So usually this configuration file will also contain some stuff like this to specify that I want to use Redis and to specify where it can find the Redis host and what the password is. But now I'm adding this scope element. And with scopes, I can just very simply specify a list of app IDs, of Dapr application identifiers, of the applications that are allowed to use that component. So in this case, I've only added traffic control server as the single scope. So the traffic control servers will be able to use the component, but the find collection servers will not. So when the find collection server sidecar starts and it starts to go through all the configuration and it looks at the components to load, it will simply skip this component configuration because it sees that it's not allowed access due to that scope. So that's a very simple way to limit your components to just the applications that you want. And for some building blocks, you can take this a step further. So for example, for PubSub, I can still use that same mechanism to specify which of my applications are allowed to use the PubSub component. But then for those that do have access, I can further restrict what they can do with that PubSub component. So for example, the traffic control servers publishes a collect find message to RabbitMQ in this case. And the find collection servers subscribes to that collect find topic. So the traffic control servers itself doesn't need to be able to subscribe, and the find collection servers doesn't need to be able to publish. So I can set this up in the component configuration file by having a metadata property called allow topics. So here I'm specifying the list of all the topics that my applications are allowed to use. So that's just that single collect find topic. And then using a publishing scopes metadata value, I can specify which of my applications are allowed to publish. So as you can see here, I've entered traffic control servers is collect find. So that means that the traffic control servers application is allowed to publish to the collect find topic. And by including find collection servers but setting it to a blank value, that means that the find collection servers isn't allowed to publish to any topic. And I can do the same with subscription scope. So here the traffic control service isn't allowed to subscribe to anything, and the fine collection service is allowed to subscribe only to the collect fine topic. Secret supports a similar way of scoping. So here I've got the government service. The government service needs access to a secret, and within the Dapr configuration file. So again, this one is not done in a component configuration file, but in your application configuration file. I can specify specific scopes. So in this case, I have my secret store set up to use the Kubernetes secret store. And then by default, I'm denying access to all of the secrets in that store, but I'm allowing access for the connection string secret. So now I can have all kinds of other secrets in that store, and I'm sure that the government service is not able to read them and will only get access to the secret named connection string, or constr, as it says here. Okay, so let's go to the final and third area, application to sidecar communication. So by default, Dapr is designed to use the network boundary as a security boundary, right? Because in production, and it's recommended that for production loads, you run Dapr on Kubernetes, then your application container and your sidecar will run on a single machine in the same pod. And that pod boundary is usually considered to be a trust boundary. So the calls from your application to the Dapr sidecar, it's just plain HTTP going to localhost. But you may want to tighten it up further. For example, if you've got other containers running in the same pods, which are running software of which you're not sure if it's totally legit what's running there, or maybe you want to expose your Dapr sidecar outside the pod to external parties, then you need a little bit of more security. And you can do that by enabling API token authentication. So with API token authentication, what happens is all of the requests coming into your sidecar need to have a valid API token. And if they don't, then the sidecar will just ignore your request and return an error. And I've got a demo for that. So let me switch over to my Visual Studio Code. And let me see if I got everything set up for this. Yeah, actually, I'm not going to Visual Studio Code just yet. I'm first going to go to my browser because I need to generate an API token. Because you can bring your own API token. It can be anything. It just needs to be a little piece of text, a string. But the Dapr team does advise you to use JWT tokens. Because in the future they may want to enable stuff like OAuth and federation and more advanced stuff like that, and then standardizing on JWT tokens is a good idea to future-proof that a bit. But it doesn't really matter right now what's in the token. I also don't need a secret. I just need a string that Dapr can use to compare if it's the correct API token. So I'm just going to copy this JWT token here. Then I'm going to go over to Visual Studio Code. And just like Edwin, I have the application running here in Kubernetes. And the first thing I will have to do is to add this API token as a Kubernetes secret so that my Dapr sidecar, my application, can access it. And for that, I'm going to use this very nice kube control command, which says create a secret named Dapr API token, and use this value that I've just generated. So if I run this command and then refresh those secrets here, we should be able to see that Dapr API token. Here it is. Okay, so now I'm going to protect the sidecar of the traffic control servers. So let's go to the Kubernetes manifest for the traffic control servers. And here you can see it has some annotations to enable Dapr. So it's this annotation here makes sure that the Dapr sidecar is injected into the pod. It also has the name and the port where the app is running and the name of the config file. And I'm going to add an additional annotation, API token secret. So this tells the Dapr sidecar to use this secret as the API token. So let me save that, and then we can apply that and make that change in Kubernetes. So if I go back to the Kubernetes plugin and then refresh my pods, let me see, then this one is probably terminating and the green one is starting up, I guess. Yep. So if I now look at the logging of the traffic control application, I should definitely get some errors. So let me kill that so we can read the error message. So traffic control service is trying to do a state operation. So it's trying to save the state using the Dapr state management building block, but it gets back a status code unauthenticated because it isn't allowed to do so because it doesn't yet include the API token in the request to the sidecar. So let's fix that. So I'm going to go back to the same manifest of the servers. And as I've told you before, I'm using the .NET SDK to talk to the Dapr sidecar. And the SDK has some built-in functionality to automatically use the API token if I've set it in an environment variable. So I just need to add that environment variable to my application, name it Dapr API token, and again, I can get that from the Kubernetes secret store. I'm going to apply this, refresh this one again. It will probably the green one. Let's just try. Still getting a lot of errors, so it probably wasn't the green one. Let's refresh again. Or refresh, okay. Let's do it again. And now you can see that everything is fine again, because now the application includes the API token in all the requests going to the sidecar. So jumping back into PowerPoint, last thing I wanted to tell you about is that you can also do this the other way around, because some building blocks, it's the Dapr sidecar that makes the call to your servers, to your application. For example, when using PubSub and the Dapr sidecar is subscribed to a topic and a message comes in, then it's the sidecar making the call to your application code. And in that case, you might want to have a similar level of security, and that is called an app token instead of an API token. But it works basically the same. You set up a secret, the Dapr sidecar will include it in every request to your application, and then it's up to your application code to validate that in your code and make sure that it's the correct token. So that's basically everything. Oh yeah, and then of course there's also concurrency control and rate limiting, which are not security measures per se, but they do guard against stuff like denial of service-like scenarios. But Edwin will go into that a little bit later. So yeah, back to you, Edwin.
Yes. So let me take over the screen. Okay, so now we're going to look at the integration of Dapr with the Azure services like Logic Apps and API management. As Sander already told, there's also integration with functions, but we're not going to look at it in this session. So we're going to focus on Logic Apps and API management. And first, let's look at API management. API management, we all know that and love that as the API management solution in Azure. It's basically a service on which you can define APIs for people to call. But nowadays, you can also run a self-hosted gateway, as it's called, a self-hosted API management gateway. So you can also define APIs that you can call, for instance, on premises, on your own, in your own data center, for instance. And you can use this self-hosted gateway and you can integrate Dapr with it. And you can use service invocation, PubSub, and bindings. So how does this work? Well, basically, if you have an API defined in Azure, so you have in the API management service, you have an API defined. And what you can do is you can run the API management self-hosted gateway on your machine, for instance. So in this case, it is just running on my machine in Kubernetes in Docker for desktop. And what I've done, if I created this setup, so I have the self-hosted gateway, and I have a customer service, which is basically just where just a .NET web API that I can call from the self-hosted gateway. It's also running in Kubernetes. So what I can do is I can register the self-hosted gateway with API management. And then from API management, I can push policies that I define. And if you know API management, you write these basically in policies. You have all kinds of policies to define the behavior of your APIs. And these policies get pushed to the API management self-hosted gateway. And then you have these APIs on premises or in the environment that this is running, and you can call them from, in this case, my local machine. So the calls are not going to Azure, but they're just going to the self-hosted gateway on the machine itself. Now, with Dapr integration, what you can do is you can add a Dapr sidecar to that. So the API management self-hosted gateway and your service is running with a Dapr sidecar. And then you can, for instance, use service invocation, Dapr service invocation, to call this service. So I don't need to know anymore where the customer service lives. I can just use service invocation, and then through the discovery mechanisms that you just didn't see working on my machine. But like I said, this was a VPN issue. I actually started it up exactly as I closed the screen, and then it worked. So it was I just had to push down the VPN. But as you can see here, you can set the backend service, and you can say, okay, backend ID is Dapr. Then you give it the app ID of the service that you want to call. In this case, this is customer service, and you specify the method, just as if you would call the Dapr API. As you can see in the example, I've defined the /customer endpoint on the API will call this policy. So this will call the customer service using service invocation. Another way to do that, to use Dapr, is to use pub/sub. So there's an additional customer created method that I can call on the API. And this will use publish to Dapr policy to say, okay, I want to publish a message. I want to use the pub/sub component with the name pub/sub. I want to publish the message to the topic customer events. And then there's some content related stuff. And then I will send the payload of the message to the message broker through Dapr. And as you can see here, then the Dapr sidecar will push this message to, in this case, a Redis cache. We were using the Redis cache as the message broker. And then the message will be subscribed to from the customer service and picked up by it. So this way, you can just create APIs using API management and then call your services using Dapr. So let's see what this looks like if we go into some code. So here I have the solution with some custom code. So in the API management setup, you can see the definition of my API. So this is just a file that I've used. This is an open API specification of my API, and I've added some policies to that. So here you can see the add customer policies, and I've used these files to create an API in Azure. So if I now go to my Azure portal, you can see this is it's called eShop API because we were using a eShop at the time. And here you see these two operations. So it's add customer, and if I look at the policies here, then you will see that this is just what we saw in the slide. Set backend service, use Dapr. The app ID is customer service, and the method is customer. So this way, I'm going to call the customer service that is running on my machine. And if we look at the other API, you already saw that, so I won't go into that. The customer service, as I said, is just another web API controller, nothing fancy. The only thing is that it has an HTTP post, add customer method, and it also uses some cool .NET integration from the .NET SDK, from the ASP.NET SDK, because this way I allow the customer created method to be called when a message comes in on the customer events topic of the pub/sub component named pub/sub. So this is how I can bind basically this API method to the message broker. and Dapr will take care of the rest. So if a message comes in, it will call this API and it will will run that code. So that's pretty cool stuff. So you don't have to write a lot of complex code to make sure that that works together. So what I can do now, I will start this up, and it will create a couple of Kubernetes resources. Because if we look here, if we look at, for instance, the API management gateway, this is just a Kubernetes deployment, and it uses the API management gateway image. So this is a default image created by Microsoft, and it has the API management gateway, and it can integrate with Dapr. And to do that, I added the Dapr annotations to it. So it gets a sidecar, and it can use this sidecar to communicate with the services. The same thing I did for the customer service, so it also runs with a sidecar. And if I now go to my Kubernetes cluster and I look at the pods that are running, so you see here I have this Redis, this will be my PubSub broker. I have the API management gateway and the customer service. And what I'm going to do now is I'm going to look at the logs of the customer service of the .NET application. So this is just the web API waiting for requests. And now what I'm going to do is I'm going to do a request on the API. And in this case, I'm just going to call 30,080, which is the port that I've used to make sure that I can call the API management gateway on my machine. So I've used a node port in this case because I'm running in Kubernetes, but I'm just calling the API management endpoint running on my machine with these APIs, these add customer and customer created events. So when I send this request, you will see eventually that the service is being called. So here's some logging that the add customer method was called. And I also get back some information like customer with this randomly generated ID has successfully been added. So this is how I can call these APIs on my machine. I define them in Azure, and I can use Dapr to call them. And this is the other one. So the customer created. This will use PubSub. So if I send this request, I will just get a 200 OK. And then here you can see from the service, customer created event was received on that topic with that customer ID. All right, so this is how you can integrate Dapr with API management. So I'm going to stop this and stop the solution for now. Let's go back to the slides. So there's another integration which is pretty interesting, and that's Logic Apps integration. Well, Logic Apps is the tool in Azure that you can use to build workflows. So you can drag and drop flows together, and you have all kinds of activities that you can use. And of course, Logic Apps has a lot of connectors to all kinds of third-party systems. So it's a really cool service. And also this service nowadays has a self-hosted Logic Apps runtime that you can use. So you can run Logic Apps basically anywhere, not just in Azure, but also on your own machine. And also this self-hosted runtime can integrate with Dapr. So you can just trigger a workflow using a Dapr binding or using service invocation, and you can use the Dapr building blocks from your Logic Apps. So what I've done is I've created a very simple Logic Apps application. And this basically starts waiting on an HTTP request. And when I do an invoke on the Dapr sidecar of the host, so I'm running the Logic Apps host with the Dapr sidecar, and then I can use the API, in this case, the invoke API, the service invocation API, to say, okay, invoke /workflows. So it knows it has to start a workflow, and then /method. And the name of the method will specify the workflow it needs to start. So you can have multiple workflows in there. It will pick the workflow based on the name. It has to be the same name as the file. And then it will create an instance of this workflow and deliver this payload. In this case, it's a license number, a brand, a model, and an owner ID. What happens next is from the workflow, I use an HTTP action, in this case, to get the owner information. And again, I'm using localhost on port 3500. So I'm using the Dapr sidecar of the Logic Apps host to invoke a person service using service invocation. Well, this is what this looks like. So people that have worked with Logic Apps before is just an HTTP call because, you know, Dapr can be called using HTTP or gRPC. So as long as I can call HTTP on localhost 3500, I can basically invoke all the Azure, all the Dapr APIs. What I get back is some information. So I get back an ID and a name and an email address. Then I use a compose action to create some kind of a payload. In this case, the key is the license number, and then the value is the information of the car and the owner. And this is what this looks like. So this is just a logic app a compose action. And I'm using all kinds of information that I requested before. Once I have this vehicle record, I will store it using the state management API of Dapr. So again, I'm just calling the Dapr API, the state management API, on my local sidecar, and then it gets stored, and then we send back a response if everything is okay. So this is really simple workflow using just HTTP to interact with my Dapr sidecar. So what does this look like in if we look at the components? So you see here the workflow host with the Dapr sidecar, and I have my person service with the Dapr sidecar. And when I start this, it will get the workflow definition, and it will start an instance of this workflow based on the name of the method that I just showed you. And then it will also create some tables in table storage, and this is for storing information about the workflow. This has nothing to do with Dapr. This is just logic apps running on-prem. Then I will send it a payload through the Dapr sidecar, and then it delivers it to the workflow host, and then it will trigger a new instance of this workflow definition. Then the get owner info will use the Dapr sidecar. It will call the person service and get back the owner information and the vehicle information. And then it will create the vehicle record. And then it will store the vehicle record again by calling the Dapr sidecar of the workflow host. And this will send it to, in this case, Azure Table Storage, because I'm also using Azure Table Storage, but it could just as well be Cosmos DB or Redis, whatever. And then once everything is done, we will get a response back. So this is how this works technically. So let's look at some code. So I'm going to open a different solution here. This is the logic app sample. Again, a very simple, just basic ASP.NET Core Web API service that will just return some data when I call it. I'm not going to look into that. If you look at the workflow, here you see the vehicle registration workflow. So this is the folder that I will use to specify which workflows I could start from the workflow host. And in this case, vehicle registration, this is the XML representation of this workflow. So you can also use the designer in Visual Studio Code, and you would see this cool layout as we just saw on the slides. But this is the workflow that will be run. Again, if we go to deploy and we go to the workflow host, it's again just a deployment because this is also running in Kubernetes. I specify using the Dapr annotations that it needs a sidecar, and I'm using the dapr.io/workflows image and the Edge version of it. It has some storage account and storage keys, so it can connect to the storage account that I just showed you. And what I just didn't show for the API management, that's the same here. This is how I make this workflow host available by creating a node port that I can access from localhost. Obviously, for production purposes, you would use some kind of an ingress to call this service from outside your Kubernetes cluster. But this is all running on localhost, so I'm just using a node port on 30,000. So what I can do now is I can go to the deploy folder again, and when I start this up, it will run on my Kubernetes cluster. And I will show you that in the logging. I will go to the different namespace, use this namespace for the logic apps, and then show you the pods that are running. So this is starting up, and it's not starting, and now it's started. So you see the person service is running and the workflow host, and they both run with the Dapr sidecar. So as you can see here, running 2 out of 2, and this is 1 out of 2, so it's still starting up. And now it's 2 out of 2. So it's running the workflow host with the Dapr sidecar and the person service with the Dapr sidecar. And just to show you that this will actually be called, I'm going to follow the logs again for this person service. And then I have an HTTP request that I can do. So I'm calling localhost 30,000. This is the node port, and then invoke workflows. And this is the name of the workflow that I just showed you. And I send it some random data. And when I send this request, you will see that eventually this service will be called. And I could be having the same issue. No, there it is. took some time. So you see that it retrieves information for some random person, and I get back the composed methods of the message with the brand of the vehicle and the information of the person. So this works, and I can do some more requests, and you see that I get information from random people. So if I now go to my storage account and I refresh this, so I will refresh my storage account, you will see that a couple of tables were created. So these flow tables are the metadata of the workflow. This is created by the workflow host. And here you see the vehicles table that I've created. And this is where I send the information using the state management API. So you see that all these crazy names are stored in my storage account. So that is how this works. So Sander, with that, back to you. How to extend Dapr. I don't know if there are any questions, but
no
I guess you would have interrupted me.
Yet.
Okay.
So I guess we failed to deliver this presentation in an hour.
Yeah, I was just wondering the same thing.
So yeah, I'm going to just pick up the pace a little bit, just not to go over too much. But I do want to show you how to create your own components. So all of the Dapr components, as well as Dapr itself, actually, is all written in Golang. And you can create your own components. So components are stored inside a components contrib repository hosted on GitHub. So you can clone that repository, create your own components, and then if you want to share it with the world, you can create a PR, and eventually it will end up in the Dapr release. If you go that route, you not only have to add code to the components contrib repository, you also have to add code, a little bit of code, to the Dapr runtime repository. The reason for that is that the Dapr runtime code has a list of all of the components registrations. So it's, I will show you later in the code, but it needs to import the components from the components contrib. And then when the Dapr runtime is built, all of that code is linked together, and out comes a single executable called dapr-d, which is the executable that actually ends up running inside your sidecar container. So we're going to build a really simple component, and I've selected to create a output binding because it's a fairly simple type of component, and all of the things that you have to do is basically the same for all of the different component types. It's just the code itself that will be a little bit more or a little bit less complex depending on what you're trying to achieve within the component. So my component is going to be an output binding to write something to a file on the local file system. So it will have a configuration file a little bit like this, where you specify the name as file system, and I specify the type as bindings.filesystem, which currently doesn't exist yet in Dapr. And then I can give it some metadata. So here I've specified the folder name. So I run the binding to output the file in user/amolix/test. And once I've got it up and running, then I should be able to make a request like this. So here I'm calling the bindings API, and I'm using the name file system. So that's how Dapr knows that it should use this component configuration file, because it also contains the name file system. And then I give it a couple of things in the request payload. First of all, I give it the data. So hello world is the string that I would like to write to disk. I also give it some additional metadata, because I not only want to specify the folder name, but per request, I want to be able to specify the file name. So the file name should be out.txt. And then I specify the operation that I want the binding to perform, because bindings can support multiple operations. And then you can specify in the request which of the support operations you want to execute. And in this case, my binding will only support a single operation called create, which will create a file and write the data to it. So if all goes well, then at the end of this demo, we should see a out.txt file in the specified directory containing hello world. So let me switch over to Visual Studio Code. And first of all, let me just do a quick test for that directory. Yeah, it's empty right now, so you know there are no shenanigans going on.
So that's not showing on the screen, at least on my end, Sander. So I don't know what you're sharing now.
Oh,
Here neither.
Maybe I'm sharing. Okay, let me. You did see the PowerPoint, didn't you? Or did you? Oh,
Yeah,
I
I
shared
still
my.
see it.
Oh, I'm sorry. I shared my power screen window instead of my
Okay.
screen. So now it should show, right? Okay,
Now we see it.
that would be a silly test to show you an empty directory without showing my screen.
So you wouldn't be a very good magician then.
Yeah, so just to make sure, really empty. Okay, so in this Visual Studio Code, I have cloned 2 repositories in this workspace. So I've got the components country repository and I've got the Dapr runtime repository. So let's first add the actual code for the binding. So I need to go into the components contrib, and here you can see we've got a folder for each of the binding types. So we are going to create a binding. So I will put it in the binding folder, and I'm going to name this file system, create a file system.go file, and then I'm going to type really fast and add some code to this file. Now, I'm not going to give you a complete Go training, but I want to just highlight some of the parts in this file, because there are basically 3 important functions that you have to implement. So the first one is this init function, which will call exactly once on your binding when it is initialized, when the Dapr runtime starts up, and it passes in the metadata loaded from the component configuration file. And in this case, I'm just getting the folder name and the file name from that metadata and just store it to use later on. So in the example on the slide, I only set folder name in a component configuration file, but if I always want to write to the same file name, I can also add file name to the component configuration. Then the second important function is operations, which needs to return a list of operations that my binding supports. And like I said, I only support the create operation, so this just returns create. And then comes the most important function, invoke. So this function contains the code that's actually being executed when a request comes in for this specific binding. And the first thing that I'm going to do is I'm going to resolve the folder and the file names. And for each of those, I'm first going to look in the request to see if the request contains the value. If not, I'm going to get it from the metadata. I'm doing the same for file name. So now that I know where I want to write to, I'm going to make sure that that folder exists. I'm going to get the data from the payload, and then I'm going to create a file, write the content to the file, and just for good measure, also write it to the log. So that's basically all I need, just in 100 lines of code to create it. I'm actually not sure if Go will be angry if I remove that line. I don't think so, but I'm not taking any chances with this demo. So now that I have this file system, that Go file, I need to register this binding in the Dapr runtime. So in the Dapr runtime repo, I'm going to command dapr main.go, and here you can see all of the components being imported. So let me add my file system to that. And you can see that it uses github.com because eventually when running in production, and if this is being adopted by Dapr, then it will end up on GitHub. So it needs the reference to be to GitHub. Now, there's one other thing I need to do in this file, because you can also see that all these bindings are being instantiated here. So I need to create an instance of my binding and return it. So this will just be a little bit of code that simply says, oh, here's my file system binding, and here's the instance that you can use for that. Now, with that set up, I can now build my Dapr runtime, and it's trying to find my module. It's looking up on GitHub to see if it can find a file system, but of course it's not on GitHub yet. So I need to change this to make it work on my local machine. And I can do that using go mod. So what this command does is basically every time I'm referencing, or if I'm trying to resolve something starting with github.com/dapr components contrib, I'm replacing that with a link to my local clone of that repository. So now if I build it, it will find everything and everything will be well. And just in a couple of more seconds, this will give me an executable. Now I have Dapr installed on my local machine. So I've just ran Dapr init. So if I now do Dapr version, you can see that I've got runtime version 1.0 running. But if I want to test it, I need to override that installed Dapr executable with the Dapr executable that I just built. Now, before I do that, I'm first going to create a backup of that original Dapr daemon. Then I'm going to copy my version. Oh, I didn't mean to push that button twice. Then I'm going to copy my custom build over the original Dapr daemon. So now if I do a Dapr version, I should not get 1.0, I get Edge, because that's by default the version number from the master branch. So now I'm ready to start test my component. And for that, I need to create a component configuration file. So the default, I'm on macOS here, and the default folder for component configuration files is the home folder /.dapr/components. So in that folder, I'm going to create a new file system.yaml file, and I'm going to add a little bit of configuration to it. So here you can see the same configuration as I showed on the slide. I tell it to use the bindings.file system, and I set up the folder name. So let me save that, and now I can execute a Dapr run command and let it listen on port 3500. So that's the port where the Dapr HTTP API will be available. So let me run this. And now my Dapr instance is up and running. So now I should have some test files somewhere here, yeah. So this file makes a request. I'm going to that 3500 port. I'm calling my file system binding, and I'm giving it this hello, let's say hello Denmark. Write it to that file. So now if I send that request, I get back a 204. Okay, you can also see in the log down here that I've written to this file, and now I should be able to command click and open that in the editor, and you can see hello Denmark. So that's a really simple component. You can see it's pretty easy creating these types of components. And of course, if you want to create a component that has some very sophisticated business logic in it, it will be more code. But the basic steps that you have to take are all the same, whether it's a complex or really simple component such as this one. All right. Last topic, Edwin.
Yes. And I made a little bit of an executive decision. That's twice today.
Oh, wow.
So what I would want to do is, because we're already, it's almost a 4:15.
Mm-hmm.
So what I would like to do is give people these resources, because like I said, this is the traffic control sample that people can look at. But also maybe you can look at the eShop on Dapr reference case. Which is like the Dapr traffic control is a sample application, but eShop is actually a reference case, is a much bigger application. And that's basically a port, so to speak, or a modified version of the eShop on containers, but it uses Dapr. So you can look at that. If you want to know more about Dapr, actually, Sander and I wrote a book on it. So there's a free ebook available. It's in PDF, but you can also read it online. And if you want to have more information about Dapr, you can go to dapr.io or docs.dapr.io. And if you want to see more of Sander and myself, we have a video channel for developers called .netflix. If you like that, go to youtube.com/.netflix. And if you like it, please subscribe. And with that, I would really like to thank everyone for attending this session. I will go back in a minute to rate limiting and do that if people are interested, but I didn't want people to miss this because, yeah, we're basically an hour in our session right now. So I don't know if there are any questions, but let's see if people are interested in the rate limiting stuff, and I will do that, but then you already saw these resources. So let me see where my team screen is. It's over here. Am I still sharing? Yes.
Yep.
So I will go back to rate limiting. Let's go to my other screen here, and let's go to rate limiting. So rate limiting, as Sander said, it is not actually security, but it's also a measure to make sure that you don't do denial of service attack of your system. And a denial of service attack is usually seen as something coming from the outside, right, from malicious third parties. But we've also seen a lot of denial of service attack from the inside, or what we call friendly fire denial of service attacks based on bugs or whatever in the software. So Dapr has several ways of doing rate limiting. So you can set the maximum concurrency of a sidecar, or you can apply a rate limit. And that's basically two different ways of doing rate limiting. So concurrency is basically how many concurrent calls can a Dapr sidecar accept and handle. And if you use the rate limiting middleware, you can specify how many requests per certain time unit you will accept for your sidecar. So that's two different approaches. So how does that work? Well, first of all, the max concurrency you can specify on the command line when you start Dapr in self-hosted mode or standalone mode, or you can specify it, as we saw for Kubernetes, as one of the Dapr annotations, and you can say what is the max concurrency for the application. In this case, it's 2, so it will handle 2 concurrent requests simultaneously and not more. So let me do a little demo of that. So I'm back in the Dapr traffic control sample, and this is the vehicle registration service that I will start on my machine. And the command that I use to do that is shown up here. So I give it the app ID vehicle registration service. I specify some ports and some configuration. This is the basic way of starting the application. What I'm now going to do is I'm going to apply some load using a load testing tool. So I'm going to do 100 requests with 10 simultaneous threads. And I'm using Apache Bench for that. And it will start hammering my vehicle registration service, and it will show us the results in a minute or in a couple of seconds, basically. Or if I still have the same issue as before with the DNS, then this will be something going wrong. So what we see here is I get, yeah, this is exactly what I meant. I'm going to do this again. There's something weird going on with DNS on my machine. So sometimes it doesn't work, and now it does work. So now you see that I did 100 requests with 10 concurrency level, and I did about 28 requests per second. So when I do that again, you see similar results, about 28 requests, and I do it in about 3.4 seconds. So that is when I don't specify any concurrency. So what I can do now is I can add something. So I can say app max concurrency 1. So I will have 1 concurrent request maximum. And then I will restart the vehicle registration service with this new command. So it will now specify max concurrency. And you can also see that here in the logging that app max concurrency is set to 1. So Dapr will tell me that this is going on. And now when I give it the exact same load, it takes longer because it will have to do all these 100 requests with 10 concurrent threads. So it will take longer, and you will see that we can do less requests per second. So in this case, you see that it took 13 seconds and we do about 7 to 8 requests per second. So you see that I'm now rate limiting by specifying the max concurrency. So that is rate limiting. The other thing you can do is Dapr has a middleware pipeline. So all the Dapr sidecars build up a middleware pipeline when they start. And of course, there are a couple of components in there already, or middleware components, but you can also add your own components, and you can even write your own middleware components if you want and plug it into the pipeline. So you define that in the Dapr configuration file, and there are several middleware components available, like tracing. This is the one that's being used for basically publishing telemetry about all the traffic that goes through the sidecars, but also OAuth, which is very important when you look at security scenarios. There's a test middleware called uppercase, which will uppercase all the content to see whether or not this works. And then there's also the rate limit one, and I'm going to show that a little bit more in a minute. There is an open policy agent component that you can use to define policies on the traffic, and you can build your own. So this is a pretty versatile setup, and you can add your own middleware to the pipeline. So like I said, you configure the middleware through the configuration file. So here you can see that I can add a middleware.http.rateLimit component on the left, and I specify that I want to have maximum of 1 request per second. And then in the Dapr configuration file, you specify the HTTP pipeline, and you add the rate limit middleware component to the pipeline. So this is how you configure that. And then this rate limiting will be a policy that will be running in your sidecar. So I don't have a demo of that. So with that, we're back at the end. So this was already shown to you, but for people still here, these are the references. So thank you very much. I don't know if there are any questions or if there's time for questions, because I think we're quite on the limit now. But yeah, thank you so much.
Thank you, Edwin. And also Sander, thank you very much for a good presentation and very good and deep dive into Dapr. Very different from the first one, I must say. A lot of topics, and also worth watching again, I think.
Cool.
So thank you very much.
Thanks for having us.
And also, very much. Might need a deeper dive into some of the more technical topics where we take one topic at the time. That could be interesting.
Yeah.
And also, I would like to apologize for going over time. But again, it is recorded, so everyone that left the session can watch it later on. So we'll make sure that it will be available on the community YouTube channel.
Yeah, and we will also share the slides, so everything is you can look at it later on. And like I said, if you go to the traffic control sample, there's also an actor model implementation in there, so to describe how you can use that.
Well, thank you.
Okay.
I'm not seeing any questions coming in.
Me neither. So either people are logged off or it was crystal clear.
I think the presentation was very good, first of all.
Thanks.
But I also think that people put aside time for 1 hour and perhaps a bit more. But yeah, so we saw a few people dropping off. Oh, we are amazed with this.
Oh, nice.
Well,
that's a good one.
That's good.
Thanks.
Feedback. Thank you.
Bye-bye, everyone.
Awesome. Yeah. Thank you.
Thank you. Bye.
And now you can start fixing your